NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Recorded Future. They help security teams make more confident decisions faster. Recorded Future's technology automates broad collection and analysis of cyber threat data and delivers the rich external context you need to understand alerts and emerging threats. With real-time threat intelligence from Recorded Future, security teams respond to threats 63% faster and find undetected threats 10 times quicker. To get started, go to recordedfuture.com/securityweekly and sign up for the Recorded Future Cyber Daily. Every day, you'll receive an email with the top results for trending technical indicators, cyber news, exploited vulnerabilities, suspicious IP addresses, and more. Subscribe today and stay ahead of cyber attacks. Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com. Welcome back, everyone, to Paul's Security Weekly. I'm very excited to introduce no stranger to the show. Peter Smith is the founder and CEO at Edgewise, a microsegmentation company. And I'm just very excited to talk about the Capital One hack and AWS security aspects that I had actually stumbled across in the past couple of weeks. And Peter and I got talking. He's like, oh, yeah, we can totally do that attack and defense on the show. I'm like, sweet. So, Peter, welcome.
Thanks for having me. It's going to be fun.
It is going to be a lot of fun. And I think we started this whole thing basically based on themes that we've been talking about on the show, one of which is the all-encompassing term cloud security, which just it means more things every day as Amazon adds new services, and now Google and Microsoft have their respective services in the cloud that are offering more and more things every day. Seems like every time I cover even the enterprise security news, there's a new service being spun up. To our benefit too. I mean, there's a lot of looking at our own technology and others, like it makes sense to put a lot of this stuff. We just did a webcast with one of our other sponsors, Logarithm. They put their whole solution in the cloud, and just there's so many interesting things. It really is not even the future of security. It's where security needs to be today. So Peter, I'll let you kind of set the stage for what we'll talk about today.
Yeah, I think we know quite a bit about the Capital One breach. We know what it impacted: 100 million people in the United States, 6 million people in Canada. We know a bit about how the breach occurred and the timeframes. So,
what's interesting, different from Equifax, it wasn't like someone just was running some vulnerable software somewhere. It wasn't as easy, or it's not as easy, but more traditional. It wasn't a traditional attack like that.
Yeah, that's right. They took advantage of some things that we haven't really seen used in this way before, notably the AWS Instance Metadata Service, along with a server-side request forgery. And then they parlayed that into S3 bucket access using tokens that they found in AWS. So it's really fascinating. And the fact that we know so much about who it was, how it was done, and sort of what level of sophistication was used to accomplish the outcome, it wasn't mind-blowing. It's just taking advantage of things that are available to you by default in many cloud services. And this is by no means to pick on AWS.
No,
these sorts of things exist everywhere.
Yeah, and it just so happened I was reading an article about secrets managers and how to manage secrets within your application. As I'm getting ready to implement that and talk about it more on the shows. I read a great article that was using the Amazon's API gateway. And the way I understand secrets managers to work is, yes, it stores all of your secrets, but you need some type of key in order to unlock those secrets. The benefit being, yes, someone could get that key, but also you can rotate those keys a lot more easily when you're using a secrets manager. Not only the keys, but your access to those credentials can be rotated and all that stuff. So I don't have to store my API keys somewhere on my file system in an environment variable inside my source code, God forbid, right? I can store those in some type of secrets vault. But the trick is I still have a key to manage. And the article was talking about using, which I had not seen before, the AWS metadata service, which has some type of key or token, and using that as your key to gain access to the secrets vault and then use the API gateway to do that. And the article, and I thought it was, I'm like, this is great. It's one less key I have to worry about. I can just go pull it from my instance and we're off to the races. Yeah. And then Peter came along and kind of shattered all of that for me from a security perspective. But it's important to note, as if I'm reading articles about this, other people are too. So it's very timely.
I think you touched on something earlier about the cloud that is really highly related to this, which is there's a certain element of convenience with the cloud. It's about when we adopt the cloud in Edgewise, there's elements of cost efficiency, of not having capital expenditures. There's elements of velocity of the development organization to do more faster. And convenience is at the core of a lot of those arguments. And so you see things in AWS that are designed for convenience, but could potentially undermine security. And I think, unfortunately, the metadata services is one of the main ones. And we'll get into it.
When you put it in that context, it's, I could spin up all my own services to do this, and very likely have probably, well, if it's my code, a lot more vulnerabilities in that. But the convenience factor is I can use those services in Amazon. I give up some control, and I hope that they provide me with enough control that I can keep it secure. But a lot of times that's a configuration option, or in some cases, maybe it's not a configurable thing with what the cloud provider is offering. Therefore, you need third-party tools to come in and help control access between things, authentication, and roles, essentially, is what it's coming down to in the cloud.
Yep. Couldn't agree more. So you want to see some stuff?
Yes. Well, first, so let's back up before we get started in the demo portion. The AWS instance meta, like what is that?
Absolutely. So there's a lot of attributes about an AWS instance. And what Amazon did, it's super clever. I'm really, really impressed by how they thought through it. What they do is they aggregate all of these metadata attributes. So what security group are you in? What's the host name of the instance? What's the MAC address? What's the IP address? So on and so forth. There's just a large volume of attributes that you can have assigned to a given instance. And here's the trick. If you are on the instance and you point anything at the network address 169.254, 169.254, port 80, and you do an HTTP request, it'll give you a directory structure. And that directory structure will enumerate all of these attributes. Now, if you go on a different AWS instance, it will only see the attributes specific to that instance. So you need to be on the instance.
EC2, or does it translate into other services, or just for what we know? So I haven't looked into it either.
It's interesting. Yeah. I can't claim to know whether it is beyond EC2, but it is in every EC2 instance that you go to this address, the link local address, and it gives you all of the metadata about self.
Right. So I can see in Lambda that being not as useful.
It's too specific not to be a feature. Or what was the original intent of why did they put this in there?
That's a good question.
It's a great question.
Amazon uses it, right?
For Tons of things use it. When we look at this, you'll see there's a very large amount of systems that use this. And I think maybe it was a simpler way of doing quick lookups that didn't require direct API interactions. It didn't require you to have a developer key or to learn an API. It was simply querying for a URL, getting a response back, and knowing what that value meant. It's
almost like environment variables, but in this sense,
that's a great way of.
But environment variables can be overwritten and stomped on. In this case, you're getting a read-only basically copy of.
You know what? I really love that analogy, because just like environment variables, you really do need to think twice about what you store in it. You're not going to store the root password in an environment variable. That would be a crazy thing to do.
You know what, though? When you're deploying containers, environment variables are used all the time, sometimes appropriately, to get data inside of the container, dynamically sometimes, or from your build. But people are storing all kinds of bad things they should not store in environment variables.
I love the analogy. I think it's totally spot on. Yeah.
Cool.
It's in lieu of having config files. You just go read, instead of reading a config file somewhere, you go read these things out of the off that service.
Right.
You don't have to do any file I/O. You just run a URL and get what you need, and you don't have to remember it because that's your nodes move. You go from regions, whatever the hell. Your app knows where it is just by asking.
Right.
Yep.
Yeah.
And
Now,
here's the rub.
Go ahead.
They don't have any way of controlling access to it at all.
There is no access control.
There is no access control. It's just a HTTP request that's not authenticated, not encrypted, anything. And they actually, in their documentation, if you can see my screen, the documentation has an important warning. And I'll just paraphrase it for you. There's one line that's underlined here. It says, anyone who can access the instance can view its metadata. Therefore, you should take suitable precautions to protect sensitive data. And really, the question is, it's great to have a warning, but how?
Yeah, how do you protect it?
How? That's not answered here. And I've done some searching, and frankly, I haven't found a solution. And we're going to try to see if we can come up with one.
Now, also, when you're going to mirror the Capital One attack, and in that they use a server-side request forgery.
Yeah.
Recap for our audience, and quite frankly, myself, the details of that type of attack.
Yeah, so I'm going to put out a contrived situation. It's not that contrived. Let's pretend like you had a server that was composing widgets. And the way it composed the widgets, and the widgets were hosted by other servers. There was a web app that had a config file with a list of widget URLs that it was supposed to bring together into a single page. So it iterates through that list of URLs. They've got a little proxy function in their app that goes and fetches the data and presents it in a combined view to the user. Okay, well, the little proxy function, that's not such a bad thing as long as it's internal and private. But imagine if it weren't. Imagine if you were to pass the URL equals parameter with any URL, and your web app goes and fetches that data and presents it to you. So let me actually show you what I mean.
Oh, that's interesting. Yeah. So rather than tricking a client to visit a URL they weren't intending, you're tricking the server to visit a URL
exactly.
they weren't intending. Okay.
Effectively treating a server as an intermediate proxy that will request anything that you want. So I'll show you right now.
And server-side request forgery. Yeah.
So what I'm going to do here is start...
It's not just a clever name, Paul.
Yes, it is very meaningful. Yes,
I'm going to start a little Python server. And come over here.
Don't ask questions, Paul. Just let him run the demo.
Oh, no. Ask questions,
Is it
please.
Python?
No,
2?
he's going to ask you Python questions.
Is it Python 2 or 3?
So I am assuming this is 2 because it's on a legacy system in my test lab. So anyway, I'm going to point my browser at this this server here.
I just did that to satisfy Jeff's requirement of me asking a Python question.
Got it. So what you can see on my screen now is that my happy little corner of the internet, my web page here says, welcome to my home page. This is the default page. Now, that little proxy function that exists in this web app, let me show you what it looks like. I'll quit this and we'll just, this is basically pseudocode. All we do here is we use Flask to do a route on your root directory.
Oh,
and
intimately. When I told you I was coding all day, this is what I was coding in Python and Flask.
So what we do here is we basically say fill URL, or URL is the request argument URL. And when we create a response, we basically just string this together. And if the response gets content from that URL, it'll use that as the response. Otherwise, it'll use the default page.
That means
it's stupid stuff. You should never do this, right?
Users could put whatever value they want, and you would go out and request that URL.
Of course. And so let's do that, right? Let's just, I actually have to run the service to make this work.
Created your own proxy server, basically.
It's a proxy server, yeah. And there are legitimate reasons to do stuff like this, but it really has to be internal only. But with this, I can just hit pass in google.com And guess what? Here I am. I'm on Google, but via this little proxy app. Well, what about the AWS metadata service? If I were to go in there and I said, you know what? Sure, I could point it at Google, but I could also point it at the link local address. So let's do it. 169.254, 169.254. There it is. That is the list of directories at the root of the metadata service. And I could say, you know what? I want latest. You can get dynamic information, metadata information, or user information. And I want metadata information. Now, I'm not going to spoil the surprise. We're going to look at this in a different way.
If that's internal only, why would you make that parameter and even put it in the URL? You would just make that internal to your own object. Because I'm thinking when I do it in my code, I send parameters, but they're object attributes. They're not something the user can manipulate in a parameter.
That's why I was using the example of a service that brings together multiple widgets into a single page. It was an ill-conceived design, or simply a mistake of exposing the proxy function.
Yes.
But the point is, these sorts of things exist in people's code all the time.
Yeah.
The question is, do you know if they're exposed or not? And that isn't even the worst part of this story.
It's not necessarily easy to find either.
Not necessarily easy to find, but let's take a closer look at, this is one of three problems. Problem one was a server-side request forgery. Problem two was that it could access metadata.
They didn't restrict, even if you're going to make that available for some requirement in your app, you would restrict which URLs it could go get, not just any.
Absolutely. Yep. So let's pretend like I had access to the server. So let's get out of here. And I'm on the server. Maybe the SSRF isn't even the means by which the connection happened. Maybe I'm on the server and I'm an interactive user. I do a curl. 169.254. Okay, there it is again. I can navigate this directory by just doing this. And I can see all of the data that's there. Well, what other things could I use? I could use wget. I could use a Python script. Here's a Python script, right? I can look at get host info. So this is just a set of print statements that does the request get statement to look up the local host name, the local IPv4, and the MAC address. And when I run this, what it does is...
it's written in Python too, by the way, Paul.
Yes.
What it does is prints out a pretty printed version of the host name, the address, and the MAC. That's for legitimate purposes, but you could also do it for illegitimate purposes. How about being super subversive? Let's just use Python. Okay, so I get into Python. It is an interactive shell, relatively benign, except really I can do anything. Let's import requests and then do a print requests get and then say HTTP 169.254. I hate typing this address, by the way. The numbers are like all over the keyboard. And then we say text. Okay, there we are. So we're in an interactive Python script loading one import and able to query this thing. And let's see how deep this rabbit hole goes. We could do latest, metadata, identity. Actually, let's look at what is at the root of metadata. You can get AMI IDs, you can get host names, events, device mappings, instance ID information, MAC address, metrics, network placement, all of this stuff. But notice security groups, you can enumerate the security groups the object has, and identity credentials. So let's dig a little deeper into that. So we're in metadata. Let's go into identity credentials, then EC2, and then security credentials. Okay, security credentials for the EC2 instance. Let's look at that. EC2 instance. Oh, what is this?
Interesting.
This right here is a secret access token that I could, I don't know, maybe do you think I could get this through the server-side request forgery? Let's copy that URL and paste it in here.
Of course you can.
Of course, I have to run the server. So let's quit this and do that. Come back here and see what we get. There it is. So as a remote user with a server-side request forgery, I can pass in an internal URL, which is the AWS metadata service, and grab access tokens out of it. And if this access token had access to the S3 bucket with 100 million US citizens' private information, I now have that, and that's how it wound up on a GitHub repository. And by the way, that's why
the data did not.
That's why
they didn't access Git and get the source code. They figured, yeah.
So they were notified in July that the data had been published.
Leaked,
it had been taken from the S3 bucket at the end of March. And this is the result. This is the lawsuit against Erratic, who did this. And those were roughly the means by which it occurred. And the question I have is, how do you stop this? This isn't a one-off thing. There will be vulnerabilities in your code. There will be the ability to get either interactive access to the host or indirect access via issuing queries through your broken application. How do you stop gaining access to this critical metadata? How? And the point that I really want to raise here is that there is no answer here.
Right.
There is a suggestion that you put appropriate controls in place, but there isn't a specific answer. What I want to do is find the answer.
Yeah, because one could just say, well, in Capital One's case, they just shouldn't have a SSRF in their app, but that's just fixing the one of the symptoms, right?
Yeah,
it's not
exactly
curing the underlying issue that there is basically unrestricted access to a key, which then could grant you access to something else.
A multitude of information.
Right.
I know the key is super overt, but understanding the security groups, understanding a lot of information that's available there is a piece to the puzzle. That happened to be the whole puzzle.
It feels like Active Directory, right? In a sense. Sorry, Jeff.
In a little way, it is, right? You're publishing some internal data, incidentally. It's actually worse, though. I think
it is.
Well, in a lot of ways, because just from a request directly from the server. I mean, there's so many ways as a developer, as you know, to screw this up. And inadvertently open up that level of access that, I mean, it seems a little irresponsible on Amazon's behalf not to put some sort of access control around such a facility. But anyway.
Jeff?
Well, even...
Oh, hold on, Jeff.
So I have a question. I'm not even sure how to ask it, but because you might have said it already and I missed it, but how on any given server or instance or whatever we're talking about does putting in an IP address, which, my old-fashioned way of thinking ties to a system, how do you get an IP address to respond regardless of how, what system or what instance you're looking at? Could you flesh that out a little bit for me?
Good question.
That's what I think is so clever about the service. It is not a host-driven operation. It's in the fabric of their network. And I can only speculate how they accomplish that. But likely what is happening is the metadata service is looking at the MAC address of the device, correlating that to an instance ID, determining what the actual instance ID is, and then presenting all of the metadata for that instance, reflecting it back to the instance. That is likely the mechanism they use, but frankly, I just don't know.
Yeah, because the TCP/IP stack is on the host, not the instance, right? So they control basically everything, in whether you're running an instance, whether you're running a container, or very similar, right? They're controlling the underlying network, right? The stack is not really inside that; it's on the host or virtual hypervisor or whatever it is, right?
So to clarify, this particular IP address, and I'm looking at some write-ups on it I Googled it, and it looks like it's at least a segment that's somehow dedicated. This is all AWS.
It's all EC2 instances anytime an instance communicates with the link local address, which it's worth noting the link local address is a non-routable address. It's only available within the broadcast domain, the layer 2 broadcast domain of the device that it's the network it's plugged into. So we use link local for MDNS as an example. So when your device magically sees another device on the same network, that's typically driven by Apple used to call it Bonjour, multicast DNS. Yeah, that's all link local. Yeah. And they reserved a link local address for use in this metadata service.
That's what I'm curious about. I mean, in the old days, I would take an address like this and look it up in the domain registry and see who actually owns the space. I'm assuming 169.254 because that's up in the. That's up in the
here's the DHCP reserved.
Actually,
right?
this is a really interesting.
Well, reserved is
non-routable.
It is
non-routable.
Non-routable address space.
It's a non-routable address space that is not statically assigned. It is dynamically assigned, and the way it works is when you don't get a response from DHCP, for instance, you will claim an address or pseudo-claim an address and broadcast out who has this. If no one responds, you take it. And basically what you're doing is using ARP to determine whether the address you have or want to have, you have exclusively. So because that's the means by which link local is assigned, if they reserve 169.254, 169.254, then really all they need to do to prevent conflict is to say, make sure if you ever receive an ARP request for resolving this, that you say, nope, I have it. And then no other device will ever attempt to take it.
Interesting. So that in DH, it works even though
DHCP fails, and it's about random.
Because I've claimed the host has claimed that address, therefore it won't be assigned to any other system.
And by the way, that's the reason it only works on a single layer 2 broadcast domain, because your ARP request won't span. Without some sophisticated bridging, your ARP request won't span the broadcast domain. So when you say, I want to be 169.254, 169.5, you do the ARP request, nobody responds. You say, okay, now I am. So if somebody else comes back on and they say, well, I want to be 169.254, 169.5, you respond saying, no, that's me. And therefore, if they're compliant, they will not attempt to take it.
Choose a different address.
It's an interesting concept. My understanding is it seems like it was backported from V6, because V6 had this idea in its inception with FE80 prefix, and 169.254 kind of got backported into V4. I don't think it existed early on, but then it, because in V6 they had the ICMP mechanism instead of address resolution protocol. The same kind of thing plays there, right? There's link scope local, so it's legit what they're doing. It's just the fact that they have a link scope local server that's advertising out metadata. That's the weird part,
right?
With no access controls, you can't apply a security group to control access to this, and even if you could, they're literally saying anyone who can access the instance can view its metadata. That means any user who gains access to it, any software that happens to be running on it, either software that you know is good now or is bad tomorrow. Just because you have good software on there right now and you can say, no, it's safe, it's only good software running on the instance. Yeah, right now.
It's almost
it is quite similar to... in fact, it's worse than this, but there are some analogies here to link local multicast discovery, or formerly NetBIOS, right? Same sort of thing. It's a local broadcasting mechanism where you could discover a lot of information. Multicast DNS is similar in that respect as well. You can discover a lot of information, but it's one thing to advertise just sort of one particular aspect of information, such as some DNS host identification structure. It's a whole nother thing to advertise an entire metadata structure that goes way beyond just one particular aspect of interesting data, that takes it to a whole nother level.
And this could be accomplished in containers as well. It's almost like they created their own network, right, in Docker, which is a resource, and just assigned it to every single container that you deploy and put a service up that you can access with no authentication. I mean, storage in Docker works kind of a similar thing. They're just basically virtual resources.
So the question is, how do you stop it?
Yeah.
Any ideas?
My first gut reaction actually is on any host that I would deploy in an instant is just to flat firewall it. Just drop any traffic to that address.
That would break a lot of things. That's the problem. So for instance,
yeah.
Oh,
well, no,
yeah.
Well, you were saying AWS uses this service.
So let's see, the SSM.
Why?
SSM agent uses it. The EC2 config uses it. There's a lot of services that are tangled up in metadata. And in fact, the first question to ask yourself is, what is communicating with this service?
Right.
Yeah.
What?
Yeah.
And that alone is a very difficult question to answer. So let's answer it.
So Amazon doesn't give you as the user a way to monitor or restrict access to this service.
You can look at flow data and you can see that every single instance in your environment is communicating to 169.254, 169.254 port 80. What good is that? Everybody is doing it all the time. I need to know what software tried to do it.
Right.
Then the onus has to go back on Amazon. They've got to implement some sort of API token key or something for access control here. They have to.
Well, I'm actually wondering, would you implement another level of security beyond, so you got the key to access your S3 bucket, but then you need something else to manipulate the data within it.
Well, it's reading data, not manipulating, right? Yes.
I mean, S3 buckets is just one example of the IAM role that may have been associated with that credential,
right?
With that token. So it's easy to just say, well, for S3 buckets, let's do something more. But this is a pervasive problem. Like, is that access to RDS? Is that what is it access to?
This is the identity of the instance, essentially.
Right.
It actually highlights the general issue that exists with cloud, and that is that the control plane is moved into software.
Yep.
And when the control plane moves into software, there's ways to abuse it, right? And this is one of potentially many that are going to exist, right? It includes software-defined networking. To use a cliche almost term, it'd be a classic example, right? If you can control the control plane itself and reroute traffic, that could be bad, right? So yeah, it's a toughie.
It's a toughie. So let's figure out what talks to metadata. And what we're going to do is use Edgewise. So what you saw is that I've got a broken web app that has this SSRF.
No, it works. It's just not secure. I wouldn't say
it works.
It works.
Yeah.
It's functional.
It is a flawed web app.
Flawed, yes.
Very flawed.
It's got a feature. It's got a feature.
It's very functional. It's a functioning proxy server. It's awesome.
Yeah, no, yes, yeah. An unintended. So we've got this flawed web application. I can run any administrative tool, whether it's curl, wget, an interactive Python shell. If you're on a Windows box, you could use PowerShell, whatever the case is.
Yep.
And what I need to do is lock this down so that only my good stuff, like my ability to say, get host info. I use this. I need this. You can't take that away from me. So some of these structured scripts that need access to metadata, they should have it, but nothing else.
Right.
So let's figure out first what is communicating and then lock it down to only the things that should have the access. So what we're going to do is get into Edgewise. And the first thing we'll do is just take the all managed hosts object. And the all managed host object is just every instance in your environment. We're going to say view connections. And viewing connections, what we can see if we expand outbound paths.
So you have the Edgewise agent on this instance.
Yeah, okay. yeah, exactly. We've deployed Edgewise via SSM actually to all of these instances to make it nice and simple to deploy. So there's a lot of outbound connectivity. I'm just going to go to unmanaged paths. These are addresses that we don't directly control, like the 169.254 address. So I'll say 169.254, 169.254, and this is a list of all software and devices that communicate to the link local address throughout the entire environment. What I'm going to do is just do a spot on this. So you can see PowerShell on desktop 3 connected, Kubelet on Testa 1 connected. We've got the Amazon SSM agent, which is the configuration management agent for Amazon. You've got the EC2 wallpaper. So on a Windows box, this is, desktop 4. The desktop will have like information about about what the instance is, its size, and all of that. Well, that's where it gets it. EC2 config does. So let's just select all and go through the list quickly. I don't want that. I don't want my subvert get Mac. I've been playing around quite a bit, so there's a bunch of cruft in here. SQL EIP. This is how SQL Server does customer experience improvement. CEIP. They get information about your instance and they send it to Microsoft. So that's gone. I'm going to take my server, which was the flawed web application out. I'll take out interactive Python, interactive PowerShell, gone. I'll leave the pilot agent. I'll take out my test, my script. I'll leave Kubelet. I do not want Internet Explorer to be able to access it. I'll say get Mac is gone. I'll say get host info, which is the one that I use. It's important to me, stays. I'll leave EC2 wallpaper. Why not? Get rid of curl. And I'll get rid of a bunch of test garbage that I was playing with.
Now, conceivably, if an attacker had a shell, they could find a way to get access to this.
Not in a minute.
You're going to take away the shell as well, right?
I'm going to take everything away.
Okay.
So the only thing that we'll be able to communicate is we're going to create a segment. And this is going to be a segment, a list of software. So I say create source segment.
In your product, you can say this Python script has access, but the shell...
that's cool. What I'm about to do.
That's really cool.
Seriously.
Yeah, I like that.
So what I'm going to do here is I'm going to call this AWS Instance Metadata Clients. And I'm going to say create. And in just a second, it'll refresh and you'll see the object here. There it is, AWS Instance Metadata Clients. So this is every instance in my environment and every piece of software that will be allowed to communicate with the metadata service. So the first thing we need to do is put a default block in, right? Just like a firewall, you say, by default, I don't want anyone to be able to talk to the metadata instance unless approved. So the way we do that is we go to sentence policy builder, and we take the all managed host object, and literally we just say local unmanaged, expand it. It shows the link local address right there on port 80, and we say block. And then we say, okay, now AWS Instance Metadata Clients. What I want to do is I want to say local unmanaged 169.254 approve. So there's two policies. It's simple. All managed is denied to 169.254, 169.254 port 80, and AWS Instance Metadata Clients is allowed. If you are not in that allowed list, you do not talk to metadata. So we're going to apply.
So I got a question.
Yeah, go for it.
I first of all love the fact you can do this, on scale, but how's that any different than what I said? And what I said was I drop a firewall rule in to stop traffic to that port, that service, right? That's what you're doing.
Yeah, with a very significant difference, which I'll show you right now.
Okay.
So we can actually chat about it first. The main difference here is that a firewall can say, this address is or is not allowed to talk to that remote address and port. What we say is this specific script, this specific application, this specific binary is or is not allowed. I can say PowerShell as an interactive shell is not, but this foo.ps1, this specific PowerShell script is. I can say Python as an interactive shell cannot, but getData.py is. And that's exactly what this is all about. So let's see what this looks like. So
okay, I'm sold already.
So let's do it. First, we'll start with get host info, my little Python script. Okay, that worked. Excellent. What if I did Python interactive, and again, I did import request. Gotta learn to type first. Import requests, and then print requests get, and we do HTTP. And text. Ooh, what is this? Oh, interactive really cool. Shell just got a permission denied for awesome. Accessing the metadata service. Now, what if I took this one step further? What if I was clever and I said, you know what, that script that was allowed?
You want to edit it. That's where I was going.
Own it. Okay. So what I'm going to do is I'll copy this script and I'll say subvert.py. I'll go here and I'll say yank it, put it, and change it to, I believe it was local IPv4. Oops. Great. Nope, permission denied. What about curl?
But now, if you edited the gethostinfo.py,
doesn't matter.
If you change the,
let's do it.
Does the signature change?
Let's do it.
Does the signature change?
Let's do it. Permission denied.
So if you just edit that.
Yeah, I'll do the exact same thing. Yank, put.
Oh, you didn't save your changes though.
Oh,
yeah, you did.
Oh,
yeah,
I did. Q bang.
Yeah, no, there's 2 lines now.
Your screen is cut off. Your screen's cut off. I'm sorry.
In case there is any question, let's just do this again. Yank.
It's on the upper screen. It's shifted, so I couldn't see the I couldn't see the W.
No problem. Get host info. Nope.
Yep.
Sorry.
So it knows that file changed.
It knows everything. Let's go one step
really
further.
Cool.
Let's do one step further.
It did that. That's really awesome.
I'm gonna start my little flawed web server.
Yes, your flawed web server.
My flawed web server. And I'm going to come over here, and the first thing I'm going to do is copy this so I don't have to type it again, and say, great. So the proxy still works.
Right. You can go to Google.
Yep.
Sure.
The point of this solution was not to stop that, but what happens if I point it at metadata services? Nope. Sorry, permission denied.
It's awesome.
So that took me, how long do you think it took me to build 2 policies and narrow down a list of the things that should be allowed to communicate?
Yeah, I mean, even if I had to watch a video of you doing it and then go do it, it's still not that long.
Yeah.
Well, it's like, that may have taken 5 minutes out of my life I'm never getting back.
Right.
Come on.
Yep. So literally,
no, it's cool.
There isn't another way to stop access to metadata services. It's this, and I don't know if this is kosher, but I'm gonna give it a go anyway. Seriously, between now and the end of the month, if you saw this on Pulse Security Weekly, and you go to our website and fill out the request demo form and just say, I saw the AWS thing on Pulse Security Weekly, and you say, I want to protect my AWS metadata services. We will give you a package for AWS that is a fraction of the price of the full-blown microsegmentation solution. It'll be a no-brainer decision.
That's awesome.
That's very cool. So, operational question. You've got everything locked down, which is awesome. And so I'm developing code, and I updated my Python scripts. How big is it a deal to say, now these are the real ones, update all the signatures?
Trivial. So scripts are a little bit different than binaries.
Oh, well, whether I change the script to the binaries,
Yeah. So I'll show you. So there's two things. For binaries, we actually have a patent on similarity scoring to be able to automatically group like objects together. That's what this little Stack Overflow icon is here. So if I select this guy and open up the sidebar and show application details, what you can see is there's actually two distinct instances. There's a SHA-256 of Python 3.6, which is different than the SHA-256 of this other Python 3.6. So two completely different binaries, but executing the same script. So the binary changed, the script didn't.
Right.
We look at all of the cryptographic properties. We do some fuzzy match comparison, and we merge those together so that there is zero administrative overhead. When you make those changes, you see these little Stack Overflow icons pop up, and that means we have automatically merged the identities for you. Now, script level changes, because they are so easy to change, what that would be is if I come to this app collection, AWS instance metadata clients, I can do one of two things, or two of two things. I can come in here and modify the definition simply by selecting the script, or we have something called register CLI, which allows you to register the SHA-256 of an executable. So for instance, if I had a continuous integration and continuous deployment infrastructure,
my scripts are changing
the last step of the CI/CD pipeline is register CLI, putting the SHA-256 into the list of trusted software automatically. So really simple to integrate into most DevOps processes. You could do the same thing with a configuration management system as well.
Right.
Thank you for asking the question I didn't manage to answer, because that was next on my mind. It really was. I was thinking, shit, how do I enter? Never mind. Yeah, you got it.
So that's it. That's it really is that simple. Like, we've got this big problem, and
make it harder. Make it harder.
Yeah, I'll try.
Said no developer ever.
That was an awesome demo.
Cool.
Loved
Yeah,
it.
very nice.
Very
Very
cool.
nice.
The fact that we don't have questions and we're sort of speechless right now is very telling. It's very, very telling.
No, I mean, you guys have you've nailed it by connecting the application, the process, to the actual traffic flow. Hence the word microsegmentation. That's exactly what needs to be done. So.
By the way, if those processes were containerized, nothing changes. If those were containerized processes, again, containers are just attributes on a process ID. That assign it to a namespace. From our vantage point, it is still just software. You apply software to software. If it's containerized or running on bare metal or running in a VM or an AWS instance, it doesn't matter. It's software. We apply the policy to the software.
And when I deploy my containers, I can update the ID, the hash.
Oh, yeah.
Right.
Yeah, and by the way, I should note that if I come down here and I say enable auto update, what it will do from this point forward is look at the definition, 9 applications on all managed hosts. Well, what that actually means is it will allow this list of software to access metadata services on any host that is an EC2 instance now and in the future. So you don't have, when you provision new instances, this is completely automatic. It automatically updates.
Carries forward.
Yep.
Right. So what's the overhead on the individual instance?
It's not zero. It's never zero.
You would not be able to measure it. I would be shocked if you could. I would be shocked. So one of the Fortune 500 company on the West Coast that deals with a lot of tax information, I can't really say who it is. They are a customer. They hammered our system with very high volume backup traffic. What they saw was 0.1% maximum CPU usage. Max.
Right. I asked the question because so often when we're talking about improving security on systems, the big pushback is, well, you know, you're going to add more overhead to running my system that I'm paying for by the cycle. Okay, I'm being a little bit general there, but you know what I mean. And when it's, you know, 0.1% overhead, it's really hard to do the pushback. Does that make sense?
It makes perfect sense. We built it the way we built it to be suitable for high-frequency trading platforms. Our latency, the latency we add to make a control decision, under normal operating sort of strain on the system is somewhere in the 5 microseconds range. It'll stretch up to 10 microseconds if it's under heavy load. So we're talking about, just to put that in perspective, those numbers might not actually mean anything to anybody. A typical NGFW will make a control decision in around 100 to 125 microseconds. We make a control decision in order of magnitude faster.
Yeah, that's not to mention developers making changes that introduce a lot seconds, not microseconds, right?
Yep.
Right. I mean, your user's not going to be responding to microseconds of delay. They're going to respond to seconds or even half seconds. You're way below the I'm going to notice threshold.
The point-to-point latency of a 10 gig Ethernet connection from an application through 10 gig, I don't know if that includes a switch. It may or may not. Is 8 to 10 microseconds.
Wow.
So we're literally talking about the speed overhead or latency overhead of one of the fastest network fabrics you can buy.
You're struggling not to say wireline speed, aren't you?
It's always a struggle. The struggle is real.
Well, I mean, again, I go back to when developers change code, you could introduce some really I mean, I've done it in our own application, right? You do something, you're like, oh my God, that just introduced 5 seconds plus is really noticeable by the user.
You know how you fix it? You build a little proxy, and you try not to make sure that it's exposed publicly.
Build a proxy, Paul.
Right? Yeah, I think database, what I'm struggling with now performance-wise is database commits, right? Anytime you write to the database, that's a huge performance. I don't know if you have the stats on that, right? But it's significant. So if you get programmers that are sloppy, and you're like, oh my God, like every time they're doing something, they're writing to the database. That's probably more common in applications than we'd like to believe, right? Or maybe we do believe that, but
definitely in the milliseconds range.
Yeah, for sure, right? And those add up too. So,
and if it was one of my queries, it would be in the seconds range.
That's what I'm going through, right? Yeah. Yes, Jeff. Jeff, you're muted, my friend.
Sorry about that, and I had such great things to say. I'm curious. So, you know, we're sort of teasing Paul a little bit about his coding. He's teasing himself. How does a developer that's working for a smaller company that's either, you know, working directly in AWS or it's going to end up in AWS, how do they make use of all this in a practical sense?
All this being AWS or Edgewise?
All this being Edgewise, what you guys are offering.
Well, I think for a small organization taking on microsegmentation, you always need a starting place. And frankly, I can think of no better starting place than what we just saw. It is a glaring wound that needs healing. And it's simple to wrap your head around what are admittedly novel concepts. I don't think anybody has seen something like that before. I mean, I haven't. And so I think you have to wrap your head around the idea that you apply policy and allow access between software and solve a real problem while doing that. This is a really great example of doing that. You learn the platform, you learn this new mechanism of control, and you actually add value to your security program. What more could you ask for?
Yeah, I think your ability to buy like just this small chunk, right, is a great start. Because I had similar questions, because we are a small, like Jeff, we're a small shop. We're looking at hiring another developer, but we're small, but we still have those security requirements. Yep. So,
yeah, I think another aspect of this is visibility. Really, it's still quite hard to understand what really is happening in your environment, especially when it changes so frequently and rapidly. And one of the elements of what Edgewise does is full topological mapping of the environment. So you can map out every piece of software and device communicating throughout the infrastructure, and then group them into higher level business constructs. And in fact, the machine learning system will do that for you. If you're willing to let me show you very quickly.
You did that demo before. That's a great point to Jeff's question. Auto microsegmentation, is that what you call it?
Auto segmentation, yeah. So when you're looking at visibility, for instance, you might care about just looking at paths. So if I want to look at paths, I could say, let's view connections for Active Directory. I can look at that at 3 different levels. A top level, which is really about the group of Active Directory servers. And from that vantage point, I can see all devices and software that communicate in and out of Active Directory. Now imagine this was a PCI environment, and you have an auditor coming in. Well, instantaneously...
like Jeff's our resident PCI expert. So
you're saying Jeff's magic words.
Yeah. You have a view of everything that communicates in and out of the PCI environment. You can go one level deeper. You could say, I want to know about the host. And if you really wanted to, and again, expand it and you can see everything that communicates in or out. If you want to go one level deeper, get down to the software level. Do you want to know what talks to your LSAS process that's inside your PCI environment? Well, you click on it, and there is a list of every piece of software and every device that communicates. Now, all of this data is that's 3 levels of vertical visibility, but you also have horizontal visibility. And what I mean by that is, let's say I wanted to see how LSAS interacts. So LSAS on accessed from desktop 01, SVC host is what's communicating with it. Well, I can go horizontally expanding as well. So I can see RDP scan communicated with SVC host, which communicated with LSAS. And you can expand that out 5 degrees. So I can literally look at 5 degrees of attack paths that ultimately arrive at a given service. Now, tying it back to what you were actually asking, that's about groupings. That's about specific topological questions. So let's rely on machine learning. I want to know about a front-end service for my business application. So I expand machine learning and I say, you know what, show me host segments that contain my load balancer front end. Okay, there it is. So there's an object here that contains this server, and it grouped together, here's another example. It grouped together all of these systems because they represent the business object. I can now look at the topology of the business application without having to do the groupings myself. The machine learning system did the grouping for me. The last thing I would say is, so you get this automated grouping of your business applications, you get a full topological view, you get the ability to control at a software level, and you get monitoring that fully integrates into your SIM. So the actions that we were just taking, let's look at those. If I look at enforcement events as an example, and I look at allowed from desktop 4 EC2 config. Well, let's expand that and see what it is. Well, this is an allow connection from EC2 config on desktop 4 using this address going to the metadata service, and this is the policy that caused that to occur. So we're telling you why things occur, and we make all of this data available to your SIM. So let's say you wanted to take the opposite. I want to know blocks that occur against metadata service. Literally all I do is I say subtype equals blocked, and I say I want to know for a specific target or whatnot. I can see every single block action that occurred and why it occurred, and all of this data is pumped out into your SIM via an integration that downloads these JSON objects and imports it into the common information model of the SIM. So all of this data is available to you instantly in your SIM.
That's really cool.
So, I love the way you actually avoided saying SIM of the SIM there.
That gives me chills even thinking
Right.
about.
Uh-oh. Now you've done it, Joe.
Yeah,
So,
now I have.
so are there other environments that have the metadata risk beyond AWS, or is this really only an AWS phenomenon?
My understanding is it's becoming more common. It's admittedly a very clever service.
Yeah.
It has to be handled carefully. And so clever things tend to permeate, right?
It's functional like your flawed web application.
Right.
Yeah, it's functional.
So, but what if I rang you up and said, I think I got this same problem with, say, Azure. How big a deal is it for me to deploy your solution on Azure?
It works no differently. We can deploy automatically through group policy on Active Directory or through SCCM, Puppet, Chef, Ansible, SaltStack, SSM. Any configuration management you have, we have a script for you to do instantaneous deployment. You instantly get the visibility. You instantly get the ability to build those two policies to protect it.
If you implement that when you deploy new resources or systems to Azure, or Google Cloud, or Amazon, the agent collects that information, right?
Exactly. And it's worth pointing out, this isn't even just about metadata services.
No.
Think of RDS. You've got an RDS service endpoint. And what that means is that things can communicate with it that shouldn't be able to.
Mm-hmm.
Use Edgewise to make sure that it's only the specific Java jar that is supposed to talk to RDS that is talking to RDS. And you can sleep soundly at night knowing that nothing else can communicate with RDS. Nothing.
So you can't put an agent on RDS. You put it on the things that should be allowed.
Exactly. And you say all your EC2 instances, they by default may not talk to RDS. Well, except for foo.jar or script.python, .py.
Yeah. And only the right version of it. So the reason I was asking is because as we've been focused on what this would value to the smaller business, but I know a lot of the larger ones are doing a multi-approach. They get not just AWS, they've got Azure, or they got AWS and Google or whatever. And I was thinking that if the same answer worked for multiple environments, that makes it a win that's so much better for everybody.
What I would actually do is I would say take the app collection, get rid of the machine learning recommendations, and I would have all of these cover every piece of software on every device independent of cloud platform. And then simply build one policy from that list for AWS, one policy from that list for Azure. It's still working on one list of approved software that should be able to communicate with metadata services.
Right, across all your cloud providers.
Across all of your cloud providers.
And then hook it in so when you're deploying to any cloud provider, it automatically gets that policy.
You don't need to maintain multiple lists here. Maintain one list.
Right.
We're downshifting to KISS, which is important.
Very. Especially as complex as managing all those cloud services.
No, I
mean, think about managing security groups alone. This was easier than managing security groups.
Right.
I was about to say, if you go back and contrast with the traditional firewall deployments, the biggest challenge, and probably most of us in this room, quote unquote, virtual room, have been some sort of centralized firewall administrator some time in our life. And classification of those assets and managing all the little groupings is a total pain in the ass. I mean, I don't know anybody that did that well, and eventually cracks form, right?
Right. And today it just becomes obsolete. You can have the best managed firewall in the world, but how do you manage your resources within any cloud provider, let alone across multiple cloud providers? Because the air quotes firewall is now, like Peter's saying, it's security groups now that you have to manage on top of your firewall. So think about how many cracks exist in
cloudy firewalls.
Well, I think a lot of us have been saying for years, the closer we can push that security boundary actually to the edge, to the application, the better off we are. Well, Peter's just shown us how we can do that. So, well done.
Thank you.
That's all I can say.
The other huge part is you've set this up, and you could go through it with somebody in about, I don't know, 20 minutes, let's say, and they'd understand what's going on in a repeatable way, as opposed to it being still black magic after multiple hours of going through it. That's huge for success.
If you are an AWS customer and you contact us and say, I want to protect metadata services, I guarantee you, if you use SSM, we can fully protect your infrastructure and AWS metadata services in a 2-hour phone call from start to finish.
It's awesome.
It's a big statement. Yep.
Where's my stopwatch?
Bring it. Bring it.
Very nice. Very nice.
I love it. Thank you.
That was awesome, Peter. Thank you so much. And it's edgewise.net if you want to go there and request a demo. Say you heard about the AWS metadata protection here, and special treats will await you.
Yeah, absolutely.
That's awesome. Love the segment, Peter. Thank you so much. With that, we're going to take a break and switch to some pre-recorded interviews that the team did at the Social Engineering Village at DEF CON this year. So stay tuned.